All right, guys. So we're going to finish up the lesson here. So what we covered yesterday was vertex form. Y is equal to a times x minus h squared plus k. And in this form, it told us that the vertex is the point h comma k, and the axis of symmetry is x is equal to h. The other equation we had was standard form. Y is equal to ax squared plus bx plus c, where the vertex is negative b over 2a, comma, f of negative b over 2a. And the axis of symmetry is our x is equal to negative b over 2a. So these are the two formulas that we covered yesterday. Yes? So I'm just rewriting them up here so we see them again. Yeah. So we have them up here.
So do we have to memorize all these formulas for basically and stuff like that?
It's good to have a familiarity with them. But any of these formulas we can rewrite as another. Because really vertex form, if we multiply out the x minus h squared, we multiply it by itself and simplify, we actually get it into standard form. And the new one we're looking at today is this one here. And this here, we really look at as the x-intercept form. Because these two here, x minus p and x minus q, are the x-intercepts. So we did jump ahead a few because we stopped at increasing, decreasing, but we're not too worried about that. Pretty much what I said at the end of class yesterday is about all I'm going to say on it. So this is the last one we're going to look at. Now, the reason they call this the x-intercept form is because the value of p and the value of q tell us what the x-intercepts are. So if we plugged in the value of p or q into the function, we would get an equation that equals 0. It tells us where it crosses the x-axis. That's what it means by the x-intercepts. Questions on that there? Now the axis of symmetry and the vertex are really given to us by this x is equal to p plus q divided by 2. Now it's not specifically stated, but we can say that the vertex is the point p plus q over 2, comma, f of p plus q over 2 would be the vertex. Because the axis of symmetry and the vertex, the axis of symmetry is halfway between the two intercepts. No matter what the function is, it's always going to be in the middle. So if we add those 2 points, the x values of the x-intercepts together and divide by 2, we'll see where the axis of symmetry is. Well, the axis of symmetry will always go through the vertex. So it gives us the x value of the vertex, and just like we did with the second form yesterday, our standard form, we take whatever that value is plug it into the function to find the y value of the vertex. Let's look at an example and see how this works. So we look at this equation here. We have f of x equals -2 times x plus 3 times x minus 1. And again, the general form for this here is our y is equal to a times x minus p times x minus q. And really, p and q are interchangeable. It really doesn't matter which one we call p, which one we call q, as long as we call one of them p and the other q. As long as we call one of them p and the other one q, we're fine. Questions on this so far? So looking at this here, and we can write this out just so we kind of have it. What are we saying the value of p and q are? So how we have it set up, we do have p as negative and q as positive, yes? Q, or p would be negative what? And q is positive 1. Yeah, I could also have said that p is 1 and q is negative 3. We just have to assign one as one of them, and then the other has to be the other one. It doesn't matter which one we pick. We're good? So you just have to pick one and then the other. Just don't set both of them, like for this here, as p is negative 3 and q is negative 3 for this problem. Because if both of them had been x plus 3, that would be fine. But here, we only have 1 plus 3, and then we have the minus 1. Makes sense? So the first one that we can look at is the x-intercepts. Now above it, I'm going to write the general form because we said it's p comma 0 and q comma 0, yes? Because that's by definition what the x-intercepts are for this form here. And really, anytime we look at an x-intercept, the y value is always going to be 0 because we're talking about where it crosses the x-axis. And at the x-axis, the y value is always 0. What's the value of p? And q is? Those are the x-intercepts. Questions on this here? Nope. We good with this here so far? I wanted to get rid of that. Now, part of the reason I want to get rid of this is because, again, we're saying that these are x-intercepts, yes? X-intercepts where it crosses the x-axis, so it has to equal 0. So if I said x was negative 3, you don't have to put this. I'm just giving you the example telling us or showing us why this works. Is it, huh? Yeah. Because we know that this should equal what? 0, yes? For the first one here, negative 3 plus 3 is? 0, yes? Negative 2 times 0 is? 0 times 4, negative 4 is? So, when the x value is negative 3, the y value, what this equals is indeed 0. Yes? Here?
Oh, I see.
Yeah, we were just going down and working, and so it does show that this does equal 0. Yes? Yeah, you're good. Now, part of the reason that this works the way it does is based off the fact of this here. We have 3 things multiplied together, yes? Only 2 of them we can actually put a value in, yes? The negative 2 is, I can't change anything with it, but we can plug values into these 2 here, yes? And if we're looking for an x-intercept where it crosses the x-axis, we're really saying that this equals 0, yes? If I have 2 things multiplied together that equal 0, what does it mean? One of those 2 things has to be 0, yes? So really what we're saying is if we want the x-intercept, we want these to equal 0. One of these has to be 0. So we're really saying that x plus 3 is solve. So the x-intercept is -3, 0. But, okay, too far. We really don't need to go that far because we can see, okay, x plus 3, we take the opposite sign, and that's it. Does that make sense? And that's kind of the nice thing with this. We get x-intercepts for the most part. We good, Austin? Okay, vertex. And I have a feeling once we do a few more, it'll make a little more sense. Vertex. Well, our vertex, and I'll write it below, is our p plus q divided by 2, comma, f of p plus q divided by 2. Now again, when you're working on these on your homework, you don't have to keep rewriting this below it. I'm rewriting it below it so that we can see what are we matching it up, what are we using for each part of this. So each of the 2 points, what are they connecting back to for the formula? Well, the first thing we need to find is p plus q divided by 2, yes? What's the value of p? Plus 1 over 2. It could have been 1 plus -3. It could have been either way. It doesn't really matter. We're just adding those two numbers together. And again, at this point here, we could plug this all into a calculator. Because the calculator will do -3 plus 1 divided by 2, and it'll just spit the answer out. Well, -3 plus 1 is -2. And -2 divided by 2 is -1. For some reason, the note sheet really likes using -1 or 1 because it came up several times yesterday, didn't it? So what that tells us is the vertex is -1. It also gives us something else. What? The axis of symmetry. Because the axis of symmetry was equal to what? P plus Q over 2, yes? Which we found out was -1. And hopefully you've noticed that occurs pretty much on every single one we've done, isn't it? Whatever the x value of the vertex, the axis of symmetry has that same value. Yes, well, it will always have that kind of matchup because we're talking about y equals, so it's a line going straight up and down. And it always goes through the vertex. So one of the values of the vertex will match with the axis of symmetry. So we'll talk about some parabolas that actually open to the left or right. So it wouldn't be a line straight up and down, it would be a horizontal line. So it wouldn't match to the x, it would actually match to the y. So it will match to one of the values, depending on which way it opens. And when we get to those, it'll make a little more sense. We won't cover those till next week. So the last thing we need to find is the y value of the vertex, yes? So with standard form, what did we do? We took the x value of the vertex and plugged it back in, yes? Same thing here. So we're going to take the function, -2 parentheses. Here we're going to do -1 plus 3 times -1 plus 1, yes? Sorry, not plus 1, minus 1. I was about to say, if it was plus 1, that would have made it 0. Questions on this so far? Anything that doesn't make sense? Can we plug this whole thing in the calculator? Yeah. If we did it by hand, -1 plus 3 is 2. -1 minus 1 is -2, yes? Then we can multiply these three together. How many negatives do we have in these three numbers being multiplied? 2. So the product of this should be what? Positive, yes? Okay, so we know it's positive. I'm not going to worry about the signs. 2 times 2 times 2. I mean, that's how I would do it. But again, there's nothing wrong with doing negative 2 times 2, which is negative 4. Negative 4 times negative 2, the negative negative make a be positive a. So that tells us the x value of the vertex is 8. And that's it. Questions on any of this here? And again, it probably feels like there's some trick, something that we have to do, but it's really, this is it. We're really looking at the formula and matching up the terms. Looking at the formula, matching up those terms. And it's really, that's it. That's all we're really doing. Okay? Any questions on this? Let's look at the next one. So I finally got around to pulling all the graphs off of these. And I'm going to pull them out of the notes soon too, because it gives you all more space to write instead of trying to fit it in that little small margin. So we want to find the x-intercepts, the vertex, and the axis of symmetry. I'll have to scroll down a little bit. Now the axis of symmetry, we know we're saying x is equal to p plus q over 2. The vertex is our p plus q over 2, comma, f of p plus q over 2. And here we have p comma 0 and q comma 0. And again, I'm putting this back in so we can see what we're referencing back to. What does it connect to? And if you find that helpful, having that written in above or below, just or next to it, write it. If you don't, if it is, you don't feel like it's necessary, you're fine with how they connect together, you don't have to write it. So use it if it's helpful, don't if it's not. And the first thing we need to find is what? The values of P and Q, because that's pretty much what we're using for this whole thing, yes? So we just need to pick one of the values for P and one of the values for Q. So what could our P value be? 4. And we could plug that in for P. And the other number that goes with it is 0. Q's value. Almost. Yeah. And I needed to write that above it too. Because our formula for this is A times X minus P. But again, having at least that is helpful, especially on the tests when the test comes around. Because again, if you got at least the number right, you're about halfway there. Yes. Because the formula is X minus Q or X minus P. And the only way we can get it plus inside there is if we have a negative and a negative. Negative and negative make a plus. Yes. Exactly. That's the right thought. You're just a step ahead. No, that's perfectly fine. I do the same thing too if I'm not watching it. Any other questions on how we got to this point so far? So we know P and Q are 4 and negative 2, yes? So to find the vertex and really the axis of symmetry, we're going to add those two together. Huh? So let's see here. So 4 plus negative 2 over 2. Yeah. 4 plus negative 2 is 2. And 2 over 2 is 1. I don't know what it is with these problems. They like picking. Yeah, no. Incidentally, it's just working out that these are 1. Because it's, again, it's possible to have fractions or decimals for these here. So the axis symmetry is also 1. Yes, we'd plug 1 back in. Because we can do this in a calculator also. We'll close that. So the y equals is where we can graph. We can graph any of these here in y equals. So I can say clear. So we had -1 alpha y equals enter third. Yes? Then it was x -4 times x plus 2. So I'm just showing you all this here, how we can use the calculator for it. And if we hit graph, we get this here, yes? So we said the x-intercepts were at -2, 0, and at 4, 0. Does it look like it crosses those? If you see above graph how it says table, because y'all used tables before, you probably weren't too happy with them. Because in Algebra 1, Ms. Kendall made you create tables. You made the little t either to the side. You had x, y, and then you picked x values, plugged them into the function to find their corresponding y values. Let me write. Hold on. This here is a table because we're creating a table of values. Well, if I go on. So this here, since it's in blue, any button on this that's in blue, we hit second to use it. So if I go second graph, I have a table. And at -2, we can see the y value is 0. And at 4, it is, what did we say the x value of the vertex was? What's its y value? So I can also show you this. If we plugged it in, -1/3 times 1 minus 4 times 1 plus 2, we'd have -1/3. Well, 1 minus 4 is -3. 1 plus 2 is 3. Yes? Well, there's 2 ways we can go about, doing this, and most of it's just how do you prefer multiplying 3 things together. So we can do the first 2, -1/3 times -3. Well, the negative and negative would make a positive. What's 1/3 times 3? Well, it would multiply on top, yes? Which would be 3 over 3. 3 divided by 3 is 1. And 1 times 3 is? Yes. Questions on this here? Kind of makes it a little bit nicer. Yeah, from the function. Now, I will show you this other feature. If you notice above trace, it says calc. And it's not standing for calculator, it's calculate. So if we go second trace for calculate, these are the ones we can do. So the first one's value, the second one is 0. The third one is minimum, the fourth one's maximum. The fifth one's intersection. So if we're looking at 2 or more equations that we've graphed, where do they cross? Where do they intersect? The third one is dy by dx, kind of talking about derivatives. And the last one is integrating, integrals. But I'm going to pick value. And what it's asking me is to name a value. So say instead of 1, they told us that the x value of the vertex was 1.5. There's a y value. I can calculate it. It'll do it for me. As long as it's not outside the window. Because here, the x values that is showing up. Yep. And that's fine, because again, these calculators are nice and handy as long as you know how to use them. And again, for the most part, if you're not doing anything outside of mathematics after this, or you're not going into engineering or those kind of fields, these calculators aren't, you won't need them. So, yeah. Yes. And if you're wanting to kind of refresh on any of these here, there's a YouTube video. Because again, TI 84 plus, and then kind of describe what you're trying to do. And it'll generate video after video. But any questions on this here? Let's look at this next one. For this one here, and especially on the test when we're given these here, you should get at least half of each x-intercept correct. Because what's one number we know for both of these points? Is for which one? The y. You should be able to get this half of it every single time, because the y value of the x-intercept is always 0. Y value of the x-intercept is always 0. Now, what's our P and Q for this here? -1 and -5. Vertex. So the vertexes are what? It's the, which is our -1 plus -5 over 2. And again, I didn't write them back out. So if you want to write them back out and you find that helpful, do that. If not, don't. You got them? If you need to use the water fountain, you can. Okay. So we just need to simplify this here. -1 plus -5 is -6 and -3. So we know the x value of the vertex is -3. Axis of symmetry. X is equal to -3. Last thing we need to do is plug it in. Now it might be a little bit easier. Yeah, you can just set it over there. Anywhere, yeah. So we could say -3 plus 1, close parentheses, open parentheses, -3 plus 5. And we can type this in, yes? On some of these here, because again, on the ACT, you can have two calculators. You can have the graphing calculator, and you can have the 30XS, the yellow one, yes? And for stuff like this here, do y'all feel more comfortable trying to type this in on the graphing calculator or the yellow one? Use the yellow one. Because you can use both of them, especially on the ACT. On the test, you can use both of them. Because for some of the stuff on the graphing calculator with matrices, which the other one can't do, actually graphing the function and some of these special features, I use the graphing calculator for. If I'm having to type this one in or the last one, I'll grab the 30XS because I can type that in so much faster on it and get it done. But if we type this in, or do it by hand, -3 plus 1 is -2. -3 plus 5 is 2. Negative times -2 is 2. 2 times 2 is 4. So the vertex is -34. The other what? Yeah. You're good. But again, it's good to ask those kind of questions. No. And again, it's good to ask that because, again, it's as long as you're, again, making that connection now and not questioning it and trying to figure it out later. Does that make sense? Yeah, because I distribute the negative here, yes? But how many of them do we have? One. We only have one negative. Because when we multiply left to right. So what we did is we multiplied these two together. So negative times negative 2 is 2, yes? 2 times 2 is 4. Yes, because we only got each one of them once, so we don't use it multiple times. If the 2 times 2 was in parentheses, or we had 2 plus 2 in parentheses, then it would go to both. Because if there's a plus between them, it goes to both. If it's multiplication, we're just going left to right, multiplying them as we go. And again, that's not a common, or that's a common misunderstanding. Because if it wasn't, all the posts of like, what is the solution to this equation? Where they start off with something like this here. If that wasn't a common mistake, those wouldn't exist. So it happens all over the place. Any other questions on this here? We feel comfortable with these here? Because we can look at another one if we need, but that's it. That's all we're doing for today. So on page 75, we have 3 through 9. So, yeah. So 3 through 9, odd. So label the vertex and axis of symmetry. And again, we're not graphing. 3, 5, 7, 9. 15 through 18, match the graph. Yep, 15 through 18 all. So on those there, you see the 4 graphs that are below it, yes? So you're going to pick which one, A, B, C, or D, that it matches to. So you figure out which one has the correct vertex and axis of symmetry, and you give that letter for those there. 15 through 18. Yep, so you're just picking the correct graph. So
example like A goes at 16.
Or something like that. Use the.
I know that's probably not right. But.
Yeah, so use the axis of symmetry to match the equation on the graph. Because if you notice, each axis of symmetry is different.
Okay.
Yep. Then 21 through 27 odd, or 29 odd. So not 28. Yep. It messes you all up sometimes when they do that.
Yeah, just want to circle it all down.
Label the vertex and axis of symmetry. So you don't really have to label it. You're just identifying vertex axis of symmetry. Because we're not graphing, you're not labeling it on the graph. You're just identifying the vertex and axis of symmetry. 33, correct and identify the error. Correct and identify the error. That one's a little bit easier to identify or kind of say what they did wrong. And then lastly, because you'll have to turn the page again, 53, 55, 56. Identify the axis of symmetry, vertex, and x-intercepts. Axis of symmetry, vertex, and x-intercepts. So you're having 3 parts for those there. And that's it. And I'm going to say this because I haven't said it before. I prefer if it is on a separate sheet of paper. But if you don't have anything, that's fine too. Because I've had some that are purely putting it on. I've been switching between the two. Half's on the pages I provide and then half's on a piece of paper. So it's not that big of a deal if you don't have anything or need to do it that way. But